Hey everybody, Professor Miller here again. We're going to talk about continuous forward rates now instead of the discrete rates that we talked about in another video. So if you look in your chapter slides, these forward rates are slides back in around 41 to 44, something like that. So let's start off by saying recall that when we have invest continuously, a present value grown at this is a growth factor, e to the RT is equal to F. And there's another video on my YouTube channel where I show you how we converge to this. But basically, this says that the time between compounding is infinitesimally small, or goes to zero, essentially. So anyway, how do we use this to calculate an implied forward rate? Well, if we invest in a project for $1, using for a 2-year rate, again, we're going to have a 0R2. And our notation in the slides is a little different than this, but if it confuses you, it shouldn't. So anyway, if we invest continuously for 2 years, T is 2. R, what's handy about this is you put R in as a decimal for the full year, and T is the number of years. It could be fractional years, but R is expressed as an annual rate. So if we invest for 2 years along this way at a continuous rate, we'll have E raised to the R times 2 for each dollar that we invest. Well, we know that this has to equal the amount we get by investing in way B, which will be E, R, how many? 1 year, reinvested, E, R, to this forward rate here. Let me put the appropriate subscripts in here, okay? So now how the heck do we solve this? Well, we just take the log of both sides, and we know from our theory of logarithms that if you take the log of both sides, this product becomes a sum. So, and we take the log of e to the R2, that just becomes this exponent. So that would be 2, 0, R2 is equal to 1 times 0, R1 plus 1 times 1F2. Gee, that looks pretty simple. Let's just work our previous example and see what we get. Remember, 0R2 was 4%. 0R1 was 3.5%. Okay, so let's just plug these into our equation here. So 2 times 0.04 is equal to 0.035 plus this unknown rate. However, can we calculate this? Well, let's just stay with us here. That would be 0.08 over here, and we get 0.035 plus this unknown forward rate. We subtract the 2, and what do we get? We get 0.08 minus 0.035. That looks to me like that's 0.045 or 4.5%. Now notice that's an exact answer here. In the previous example with discrete compounding, we had 4.5024%. So you might be wondering, why is this continuously compounded rate smaller than the discrete time rate? It's because when we compound more frequently, a smaller rate gets you to the end. A smaller rate will get you the same amount at the end. So hope this is helpful, and take care.